Hello, everyone. Welcome back to AWS Best Tech Skills Show. Hope everyone is having a great time. I'm your host today, Jigna Gandhi. I'm a solution architect from AWS. You might have seen me in the previous episode, but those who haven't, hello. I'm right now in NYC and it's a little bit of cloudy weather today. Why don't you tell us in the chat where are you joining us from? All right. I think by now, most of us have been doing some work or, at least hearing about AI agents. So, we thought, why don't we talk about that little more in detail today? We are seeing some big shift in, how AI agents actually learn from the experience. So today's topic is going to be just that. Right now, I would say most AI agents operate with a kind of built-in amnesia. So every interaction starts from scratch. They don't remember what worked, what failed, or even what a user preferred just moments ago. So I think that's, I would say, like a major limitations that we see. But we would love to hear from you as well. Like how many of you have used an AI assistant that just forgot what you just told it, right? So please put in the chat. Yeah, let me just give you a little bit more background about what are we going to cover today. In this episode, we are going to be exploring agents that learn. So we'll show you, how you could do that with a feature in Amazon Bedrock Agent Core, which is episodic memory. From my experience, I think this is a really powerful thing that allows agents to capture structured records of their past interactions, including the context, decisions made, and the actions they took, and obviously the outcomes that followed. So I know so many of us are builders as well, so we'll have like a demo where we'll walk through like how Agent Core memory works under the hood, how these episodes are captured, stored, and also retrieved during the execution. So let's get to it. Before we start, I do want to introduce my two wonderful guests, Mani and Akasha. Do you mind sharing a little bit about yourself, your role, what you do, and yeah, anything else that you want to share with the audience? Mani, we'll start with you.
Uh, Thank you for the wonderful introduction about the topic, and we are very excited. My name is Mani Khanuja. I'm Principal Solution Architect at AWS. I've been with AWS for over 6.5 years, and I've worked with hundreds and hundreds of customers. Even I lose the count. But that's the best part of the job, that I get to work with customers. I get to, help them in building their agentic platforms, sometimes their applications. I also work very closely with the service team on Agent Core services as well as Bedrock. So it's a pleasure being here and talking about, building self-learning agents. And by the way, I'm based out of West Coast in Southern California, and the weather is awesome. Not cloudy.
I'm jealous. I'm jealous for sure.
That's the intent. That's why I'm mentioning it. So, yeah, very excited about the talk today. And without any further ado, I'll pass it over to Akasha.
Thank you, Mani. Hi, everyone. My name is Akarsha Sehwag. I'm a part of the Agent Core memory team. I work as a GenAI data scientist, and I've been helping customers build their applications on Agent Core or otherwise to help them build these GenAI applications in production. And yeah, we have worked with a lot of customers and we have seen their pain points. What are the challenges that that are faced when an agent is in production? POCs are easy, like everyone can build a POC, but once it actually goes to production, once we actually want the users to use it, to adopt it, that's when we see so many different issues that we have never thought about. When we were building the POC. So that's what we are here to talk about, of how can we improve our agents? How can we, let them learn on their own so that we don't have to do those 1,000 manual updates in the system prompt and have every trace guide us of what happened, how it happened, and so on. So that's what we are here for. Let's get started. Shall we?
I do want to give a shout out to the most global audience I've seen today. Nacho B is from Argentina. We have Noor Sadli. I'm sorry if I'm mispronouncing, from Kuala Lumpur, and then we have a guest from London as well. Thank you so much for joining. All
That's
right.
great.
So yeah, how do we start? I do have a question. So like, let's start from little bit basic so that everyone has like little bit of context. So what's the biggest learning gaps that you see today? The agents don't improve, agent don't personalize their response. Maybe we could start from there and then get going.
Yeah.
Sure. So again, like I can talk about my experience. So we have seen like different types of applications that currently exist. So there are a lot of applications which are more focused on like personal assistant kind of scenarios where you need personalization is the key. So we call it as personalized intelligence, and then we have agent core memory, which where we have user preferences, so that the agent is learning about you, right? But everything comes with a great responsibility, and with agent core memory, we provide a lot of security options so that the data is, not shared. Your data remains with you. So again, whatever we are sharing even right now, based on self-learning agents and how agents can interact, it comes with a lot of responsibility and
Yes.
security, which
Indeed.
we are going to talk about. So those are the some of the trends that we have seen, right? People are talking more about personalized assistants, but what they're not talking about is self-learning agents. We are talking about a lot of autonomous agents where you have entire workflows that your agent automates, and that's where we see a lot of issues on LinkedIn, where everyone is sharing about the debacles and the success as well. Yeah, so that's why it was our attempt on. We were thinking about, when Akarsha and I were meeting and talking along with other folks from AWS. Our main concern was how we can, make sure that the agents are learning as well as we provide a secure way for our customers. So that's
Yeah.
a, attempt on doing that in the right way.
Yeah, and it's a huge gap, right? Like we see this in most of the projects that we have seen or worked on. It's a huge gap that we are seeing today. The agents, as you mentioned, right? They have amnesia. Every single time we start a new chat, they start from scratch. So they start brainstorming again from the ground zero. So that's what we are here to help you address. How to turn your stateless agents into the agents that genuinely learn and improve over time. So we'll cover in this talk, we'll cover the theory, some concepts, the platform of what AgentCore memory can do for you, and a live demo. Live demo is very exciting, so let's already start. All right. So the key question we are addressing here, so far we've been talking so much about reasoning, tool use, creating complex workflows for our AI agents. We have been building MCP servers, calling different APIs, executing code, whatnot, right? But all of these things are technical capabilities. What we need at the end of the day is to have a good user experience. And I can't emphasize this enough. We need to have a good user experience, because without having our users to adopt, who are we building these products for? So the agents, the fundamental gap that we were talking about, we have to make sure that they are able to learn from their experience. They are able to expand their horizon in terms of the tasks that they can solve. They can get progressively smarter, because not everything we can predict from the day when we are actually building this or shipping this to production. We cannot predict what kind of questions would the users ask or what would they use this agent for, right? And we don't want our users to having, repeat their same preferences or, the same asks again and again. We want the agent to be smart enough to figure it out over time and to be, be better. So how do we do this? How do we learn this? And to solve this, let's take in simple terms, and let's think about how we humans do it, right? So take this for an example. What is the progression from a novice engineer to a senior? So when we just, remember the time when we just joined a team, I remember like I wanted to be super thorough. And I would, like, any task that was given to me, I would investigate it very thoroughly, very methodically, how they say, by the book. So let's say as an engineer who wants to do some IT investigation, they would do health checks, they would check the logs, they would check the deployments, they would run the diagnostics, they would do everything by the book. And this is how our agents work today, mostly without memory. Then on the second level, so, once a few months passed, we have some more experience, right? So that's where we start remembering similar experiences. We are like, yeah, I saw this looks like there was this issue that I faced in January. So it could be something to do with this connection pool issue, for example. And this is what, let's say, mapping it to memory, this is what episodic memory looks like, where we are prioritizing likely causes. And then the third level, which is once an engineer has seen multiple different incidences, they have built an intuition around, different kind of incidences. So then they're like, oh, in my experience, most of the times this is the root cause, or this is where you would find the problem, right? So that's where the engineer is able to reason based on the previous patterns. So mapping this again to memory, we say this is where reflection comes in. So this progression that we are talking about, from starting from experiences to learning those lessons and then synthesizing those patterns, we humans do it naturally, right? But AI agents do not have this loop. And that's what we are today here to talk about and to learn.
Yeah, sounds amazing. I do want to call out a thing for our audience. If you have any questions, please feel free to post it in the chat. We also have my amazing friend Fatima Kamal on the background, who will be like a moderator for us. So if you have any questions, please put those in the chat, and we'll get right to it as we continue.
Yeah.
And also, if you have seen any other challenges with AI agents, please feel free to post that as well.
Yeah, and we can in general also talk about stuff. So
Yeah.
okay.
For you.
Yeah. And just to put some perspective, I don't know if you have heard about a story where, there was a ship, and then, different people were called upon, and the ship was stuck. There was a lot of containers that was supposed to be delivered, and nobody was able to fix. And then they called somebody who was very experienced and expert in it. And then the guy came in and just did like, one hammer somewhere, and then it started working. And then they were surprised, and it's like, oh, how did you fix it in like less than 5 minutes? And then the guy was like, because I'm experienced and I have seen this so many times that I exactly know where to, put the hammer in, or solve the issue. So that's what we're going to see today in when we are talking about self-learning agents. So there are basically 4 components of self-learning agents. And Akarsha, would you want to take us home with these different components?
Definitely. So mainly we have these 4 components, right? We start usually with memory. This is our pillar number 1. This is where we teach the agent to persist and to use the past conversations to learn from, or to get some more context about the user or about the task at hand. So here it has, the structured records of what has happened in the past, what it tried, what worked, what failed. So it has some understanding of what and why it works. And then the next level is the reflection. So reflection is where we try to synthesize some patterns. So some insights across multiple experiences to understand, hey, what are the generic guidelines? Next time when the agent is solving a similar problem, can we create some hints or some guideline for the agent to work with? So that's the part where the agent is able to learn from the patterns. Then, I mean, this is just about memory, right? Taking it from the perspective where it's not just about what happened in the past, but also how is the agent performing today. So that's where we have to add evaluation, because a self-learning agent, needs to know whether the actions that it took were successful or not. And the evaluation is what enables us, right? So as Mani says, what you cannot observe, you cannot measure. And what you cannot, so once you've measured it, it's of no value unless you evaluate it. So that's where evaluation comes in, and the agent gives, you can see how it performs, or how well the changes that you've made, or the memory, or the other components that the agent is using, how well is it able to use all of that. So you can use these components, and then as a last step, you can then adapt the agent accordingly. So you can learn, or you can allow the agent to learn from its behavior.
Yeah. So basically, there are two things. If you look at the memory and the reflection, it talks about like while you are interacting with the agent and you are talking. What happens is if you have enabled long-term memory, it can literally take insights from that long-term memory based on the task that you have, and the agent will store it in its memory, similar to what we do as humans, right? And then based on those different types of episodes, it can literally do some reflection to see what kind of patterns or what kind of frequently asked questions that my user keeps asking, how I have solved this problem in the past. So those become part of the reflection. And so this is like about the history, like, while you're talking, interacting, and it's storing and identifying patterns. And when we are saying evaluation and adaptation is like, it's not just related to the memory. It's additionally like the agent might have access to, let's say, 4 or 5 additional tools, and you want to evaluate each and every task that the agent is doing, each and every trace, when it's calling memory, when it's calling different other tools, how the agent is passing the parameters when it's calling the tool. So everything needs to be evaluated. So first you need to have visibility, which is observability. Then you need to evaluate whether the agent is doing the right thing or not. So because without evaluating, you won't be able to fix anything. Now you have the evaluation, but if you don't take any action, once you get the evaluation results, then also things will not happen. So that's where we call it adaptation, is where you see the agent, or what, if it's beyond this particular threshold, you need to maybe restart from this particular checkpoint, or self-correct yourself, or figure out, maybe change the parameters and stuff like that. So you'll see a lot of those in action. So those evaluation and adaptation are continuously evolving and continuously taking action. So think of it as continuous testing or continuous evaluation, and the agent taking action. And that's what we call as self-learning agents. And
We do have a question from the audience. Can memory be siloed by segment or customer or user type?
Yes. So within long-term memory, we have different options. One option is, so the way it works is we have a concept of actors, and actors could be your user ID or agent ID, or a combination of those. And then we have a concept of namespaces, and you can literally design your namespaces accordingly. So that can help out. And also we have, IAM policies, where you can literally have a condition or over a particular namespace, so that whatever you are doing, you are 100% sure that agent is accessing the right information about a particular user. It's very critical, specifically when you are working on agents where there are a lot of like user preferences that your agent is storing, right?
Yeah, given that we are dealing with user data with memory, we have to be very sure that the security is taken care of. And yes, so we can scope it with different namespaces. So you can scope it on the session level, on the actor ID level, or on a maybe a high level where you want to share it with the entire organization. And the Actor ID, as Mani mentioned, you can use it for different tenant or different team or different organizations. It's completely your choice. How do you want to design that Actor ID and thus the namespace? So it's a path-like structure that you can define to say how granular do you want the scope to look like.
Awesome. Thank you
Yes.
so much.
Yeah, so we were talking about these 4 components, right? And those 4 components that we described, those are essentially allowing the agent to self-learn. So the question is not really how good the agent is when we put on day 1, when we put it into production, but how is it on day 100 when it has seen all the user questions, the real user questions. So that's where we build this flywheel, so that to give a visual perspective of how self-learning works. So as a step 1, agent is able to handle the task that it was trained on. And then once it has different experiences that it captured, it has different patterns that it emerged, it has then overall some evaluation that took place, and then it adapted over time. And based on that, the user gave it more trust, and therefore the number of tasks that it does also expands, right? So it's not just that it improves on the task, but also it gains the user trust, and it's able to do those tasks faster and better and more accurately, right? And that's what we are aiming for.
A quick question.
Yes.
Like, how does it work in the backend? Like, how much volume of the data we are talking about for a simple business case? And it would be great if you could provide some view based on your experience.
Yeah, and actually we are going to do the demo and we'll show how that will work. So if you bear with us and we go through the slides quickly, and then we are exactly going to take that up and actually show you how that works. I think that would be even better. Right?
Yeah, for sure.
So let's talk about a little bit about AgentCore. So now we are talking about the general concept of how these self-learning agents work. And absolutely, this is just one way where we have shown you how we, make it work. There can be, based on different use cases, there can be even more additional components that we might not have discussed. But based on what we have, talked about, when we are talking, we'll see now how AWS services can actually help you. So for building your agents and providing capabilities to your agents, we have a service known as Amazon Bedrock AgentCore. It's literally the most advanced agentic platform, and I mean it when I say that. Uh, and trust me, I've tried a lot of things when it comes to building agents. So the specific areas that we'll be focusing for this talk, because absolutely there is no way that we can cover everything. But in the context of self-learning agents, we'll be talking about memory, which is basically learning from the past experience. And then we'll be talking about observability, because as I mentioned, if you cannot see it, you cannot fix it, you cannot evaluate it. Once you see it, if you don't evaluate, you cannot act on it. So that's where our whole, agentic loops comes into play. So we are only going to focus on these 3 for today, on how the agent learns from the past conversation. We'll go deep into memory, we'll talk about observability and evaluations. So and let's first take a quick look at the memory and how the memory works. So at a high level, when you are interacting with the agent, those are the conversations that are happening, right? So those are raw events. They go into the short-term memory. Short-term memory, think of it as like whatever you are talking to the agent, it keeps going like raw events, right? So let's call it as raw events. Whatever the question, you are asking, the agent is responding. All those events are going into short-term memory key value store.
Yeah,
Right?
all the messages or the checkpoints, anything you want to store as it is.
Yes, and even you can store the entire agent state, because as I mentioned, let's say you have a long-running agent and something happens in between. You want to make sure that the agent can resume from that state. So again, it depends on type 3 use case, but we provide you with all those building blocks. And now, whatever is going inside the short-term memory, you need an intelligent way to extract the meaningful information. So it's very similar to the way human works, right? So, for example, I'm in this conversation with you. We're talking a lot, right? But in my long-term memory, like after this conversation is done, I will remember the most important aspects. I might not remember each and every word or each and every sentence that we have spoken, right? But I would remember, oh, these were the questions that were asked, and this is how we responded back. So things like that. So what we remember as human are experiences, and this is exactly how we are thinking about when we talk about the long-term memory for agents. So then we have the agent, this memory extraction module, which exactly does the same based on the strategy. We have different strategies like user preferences. If you enable, then it will only remember the user preferences, facts, or episodic memory that we are going to talk about, um, and how it will do that. And then it stores into the long-term memory. The long-term memory, now because it's processed information, we call it as records. So we call it as memory records, which goes into a vector store, so that while the agent is talking to you, it maintains the conversation in a short term, but it can remember and extract the information. Oh, you know what? Last time, this is what you talked about. Or last time when you asked a similar question, this is what happened. So those are the things that we store it in a vector store long-term memory so that it can do a semantic search on top of that. And absolutely, there are a lot of features. It's serverless, built-in encryption, namespaces, I think we've already talked about, and also the time to live, right? So this time to live is very flexible. You can add it into your short-term memory and it works. So that you don't have to manually go and purge the, really, really older events based on your use case. So let's talk a little bit about the short term. Actually, we've already talked about the short term. Let's talk about the long term. So these are the different strategies: a summary, user preferences, semantic, episode. I think I've already talked about those a little bit. Summary is more like per session summary. So what happens is, like, you are in a session. When I say session, you're talking to an agent. Agent is responding back. You exchange, let's say, 50, 100 messages, whatever. And then if you have enabled the summary, what it will do is it will summarize the key points of your entire session and store it into the long-term memory. And it's basically in a continuous basis. So what happens is, after a few messages, it will create a summary, then you talk again. And these are certain limits, like when it creates a summary, because if it keeps creating summary for every conversation, I don't think that's a good design. So there are certain, criteria on when it will trigger the summary and all. So it's fully managed. You don't have to worry about that. But if
Quick
you want to
question.
worry about it,
Sorry
yeah,
to interrupt you. A quick question. So this long-term memory is basically RAG-based context for the agent. Like, is that accurate?
RAG. So RAG is different, but the part which is similar is the semantic search, right? So RAG is like, I have my company documents and I want additional context from and I want my agent to fetch additional context before giving me the response. But when I'm talking about memory and the long-term memory, it's literally when I'm talking to the agent and interacting with the agent, it's extracting, let's say, summary or the preferences, whatever I have enabled, and storing that into the vector store in the long-term memory. So the construct of a vector store, the construct of a semantic search are similar, but those are used in different, ways. So you can have an agent which has memory, like a human being. I have a long-term memory, but I don't have the entire book in my head, right? So that is basically, if I have to do that, then I'll basically fetch a book, and then based on the question, we'll answer based on the book, right? Similarly, that is RAG for agents, that it can fetch and get additional information based on the question from the vector store, from the documents, right? So very similar concept.
Thanks for
Okay.
clarifying. Yeah.
Oh yeah, absolutely. These are the, interactive things are the best ones. And then we have episodic memory, which we are going to go deeper. So I'm not going to cover it just yet. And then there are other strategies like override, self-managed. So if you want more control, if you want, like, oh, I want to change the prompt on how these extraction is happening, you can use override. Or you will say that, you know what, I want entirely something else. I want to build my own pipeline of how the extraction works from the short-term memory and goes into the long-term memory. That's where you can use the self-managed feature as well. So for the scope of this talk, we are going to focus more on the episodic memory, because otherwise we'll just eat up the entire thing talking about this. And this is like a detailed diagram of a long-term memory on how it works. You have, Akasha, do you want to drive us home on how this works?
Sure. So you already, Mani, you already mentioned how we are fetching the data from the chat, which is going to be stored in the short-term memory, which is mostly used for the immediate context, right? We have the entire conversation in there. But what we want to do for longer term is to extract some insights, to extract more relevant information that is going to be the long-term memory, right? So where we retrieve the memory records. So how do we do that? We wait for K messages from the short-term memory, or we wait for the X seconds of inactivity. And it runs an asynchronous pipeline per strategy, meaning, so out of the strategies that Mani had shared in the previous slide, out of that, you would choose one or more strategies, what you want to have for the extraction. And based on that, it'll run a pipeline with multiple steps. So step one is where we are extracting the relevant information. So let's say we are talking about user preferences. I chose user preferences as the strategy, right? So the step one will extract only the user preferences out of the entire chat. And we are not always talking about our preferences in the chat, so it only extracts the bits where the user is giving some explicit or implicit preferences. The second step here is consolidation. So this is where we make sure that we do not have this information already in store, or maybe there's some contradictory information that we already have in the memory store. So we look at all of the similar memories that we have existing, and then we compare it, and then we do one of these operations. So we either add a new memory. If, let's say, nothing of this kind exists already, we will add a new memory. Or if something similar exists in terms of, like, if it's contradictory, or if it's, let's say, not a complete piece of information, but the new information will make it more exhaustive or more complete, so we will update the existing memory record, right? Or let's say the third case could be where we already have this information in the vector store. We don't really need to repeat it again. So we do not add a new memory. Instead, we just skip it. So this way, we do not add more duplicates into the vector store, right? And then the third step is about embedding and indexing, where we are embedding this information and storing this into the vector store.
Yeah, and take an example, right? So for example, let's say I was talking to the agent, and I say my favorite color is blue. So then it will do the extraction. It will look at the consolidation. Do we have the color preferences for this user? It will say no. Okay, add. And then it will do the indexing. Oh, color preference, blue, and it will store. There are other things also that it will store, but just giving a high level example.
Yeah.
And then next time I come in, let's say after a few days or maybe after 2 hours, and say, you know what? I think my favorite color is white. And then it will say that, oh, let me figure out the color preferences. And then it's, oh, the last color preference was blue, but now it's white. Let me update the record. So it can again do the indexing and update it, so that it's updating the information, making sure that it's always giving you the relevant information. And next time when I come and I say my color preference is white, and then it fetches white, and I say, oh, it's the same, let's skip it.
Yeah.
So just to give you a small example, I know in reality things are very different, but I hope that makes it super clear.
Yeah.
Okay, now the exciting part. So Kasha, do you want me to take that, or do you want to take it?
As you like.
Okay.
This is favorite for both of us. We can fight over it.
Yeah, but
Yes.
I'm giving you the demo, so I'll take this up. Okay, so this is like the reason why we are very excited about that is because this is episodic memory strategy was literally launched in last reInvent, which is in December 2025. And now we are in March, 3 months after, right? So let me talk about what this episodic memory is and how it really works. So the basic concept where we are doing the memory extraction, as we showed you, remains the same, but I would say similar, not exactly the same. So we are doing extraction. Let's say you enable episodic memory. You have to, first of all, provide 2 namespaces. namespaces, as we mentioned earlier, is a way of how you will separate, your memory, and think of it as like workspace, where you provide a specific workspace where it can store the records, right? So I'm just giving you an example. But namespace concept is very similar, where you provide where your episodes in this vector store are going to store, right? So that's there. The second is reflection. So you have to provide another namespace, which should be the parent of this episodic namespace, where it will look at, oh, I have these different episodes. Let me figure out what are the similar patterns. And based on that, it will generate the reflection and then do the embedding and store it into a long-term memory. So let me walk you through how that works. So now you have events. I have, episodic memory strategy enabled. Now it will look at the turn extraction. Turn is like one turn would be that I asked a question to the agent and the agent responded back. So it will do the turn extraction. Based on the number of turns that it have extracted, then it will figure out an episode. Now, why we are calling this as episode? I'll give you one example, and it's a little funny, but I hope you'll like it. So, for example, my question is that to the agent that I am looking for properties outside of California, right? I want to be in warm places. And then the agent comes in and say, Florida. And then I'm like, oh, I don't want to be in Florida because in summers, Florida has lizards. And why? Because money is scared of lizards. Why that has happened? Because there was a past episode or interaction where money as a kid got scared, right? So, those are like, I'm just giving you an example on how these episodes work in our personal life, like, as humans, that some episodes have happened in the past. Because of that, we have our reflections. So now, like my husband, my son, they all know that I'm scared of lizards, right? So they will not going to buy a property in Florida because they know that I'm scared. So now let's translate the similar concept with agents. Now you're talking to the agents. There are turns that are getting extracted. It's creating the episodes of that particular interactions that are happening. So for example, if there is a debugging agent where I'm asking, oh, how do I fix XYZ issue? Or let's say maybe memory overflow issue, right? Or some API issue. So it will keep the episodes, it will figure out, okay, what the user has asked about, what was the response, how did we, the issue was fixed, and so on and so forth. So I keep asking this debugging agent different questions. And based on these multiple episodes, it will create a reflection. It will identify, okay, what were the different patterns that this user always gets stuck or keep asking about in the debugging scenario. And then it will also store it into the vector store. Next time when I ask a similar debugging question related to the API that I've asked previously, then it can look into the reflection and quickly reply back that based on this previous thing that has happened last time, literally we solved this using this particular way. So it doesn't have to go through all these follow-up questions and stuff like that. It will be faster. It can quickly give you the response back. So that's the main idea. So I've given you two examples where I've given you a personal example where how these, episodes in human life works. Mine is an example. And now I've also given you an example of how you work with agents by using the debugging example. And now I know because we are all builders, we need to have a demo, otherwise it's incomplete. So Akarsha, I'll hand it over to you for going through this architecture and sharing a demo with us.
Thank you so much. One thing actually I want to add on the episodic, because this it has, like, I have seen multiple times the confusion from people that the turn level extraction is different than the episode level. Why, or how do I identify? So think about this in terms of a meeting, right? Like when you're in a meeting, you take notes during that. So that's a turn. Whatever you hear, you write it down. Like, okay, this happened. And then at the end of the meeting, you try to summarize and try to find out the more important insights of like how the process looked like, what it was about, and so on. right? So that's more, let's say that's more an episode that you create. So once the goal is completed, that's when you create an episode out of it, versus when it's intermediate steps where you are, still figuring out what the solution would look like. That's where you have a turn level analysis that is being performed. Perfect. Are we sharing the screen still? Can we look at the architecture diagram?
Yeah, I guess money got dropped for some reason, so I'm not sure. But I could share your screen, which is the demo or the GitHub link, I guess.
Okay, perfect.
There is one question though.
Yes.
I think it's more of an observation, but I do want to call that out. Memory contradictions would be an interesting event that can be stored or queryable to determine if the user training is needed. And the question is like how these modules are powered by LLMs. Are these like Nova models or something like that?
So the memory contradictions is being handled by the second step that we described, where it's memory consolidation. So it's looking at the past memories and it's looking at the current ones, and it's figuring out, okay, should I update this memory or what should I do with it? Right. So that's where we handle that behind the scenes. And yes, these modules are powered by LLMs. We keep these LLMs up to the date. So we keep updating them. So it's not specific on if it's Nova model today or not, but it's about we keep updating them as new models come in. There's a science team which keeps doing the benchmarks for different vector stores for different LLMs that are performing up to the mark or better than before, right? So that's something, that's the benefit of, using a managed service. That's exactly why you use a managed service, so that you don't have to go through that pain to do all the benchmarking, to see which vector store has the best features and so on, because there's a full team sitting at AWS, which is doing that for you, literally.
Awesome. Thank you so much. I'm going to put the architecture diagram back on the screen so we could talk a little bit about the flow.
Yeah, no matter what you do, something or the other happens. There was
yeah, that's fine.
Yeah. All right. So what we're going to build today is a IT incident response agent. So this agent is receiving different IT incidents, and it's an autonomous agent which is able to resolve those conflicts and then resolve those incidents and then give you a response. So we have used Strands agents to build this, and it's built on a Flask application, which is creating that application with memory at the back end. So the memory is basically the Flask application is sending the events into short-term memory, which is being then asynchronously being propagated as episodes and reflections. So how we described how it flows into long-term memory. These are the extracted insights. And then we can use those reflections or episodes into our application, right? So what we want to show here is to see it side by side, to see how it works without the memory and how it works with memory and what changes. So let's do that. I'm sharing my screen.
Yeah.
Let me know.
Exciting part of the talk. I can say that.
Yes. Demos are always exciting, that's where you get to see it for real, what we are talking about. All right, so here what we have is a memory inspector on the right-hand side, where we can actually look at what is in the vector store. So we have 10 episodes in there, which is propagated from previous interactions, and some reflections that are in store. And one thing you notice is that reflections are more than episodes, which could be possible. It doesn't have to be one-to-one or one-to-many. It really depends on what kind of episodes have you stored before. So in this case, I hydrated the memory with very different incidents, right? So it talks about memory leak, it talks about some HTTPS traffic and so on. So it's very different kind of information that goes in. And based on that, it has created different reflections. So we will look at what we mean by that, right? So let's say we start with this question. So ask a question about, hey, API latency spiked to 5 seconds across different endpoints. And this is my error rate. It started 30 minutes ago. Figure this out. So it's investigating. It has access to some different tools, which allows it to do the service health check the recent deployments, some query logs, and then at the end, it executes the remediation, right? So incident has been resolved. It creates a summary of the root cause, and it creates some recommendations, right? So this is what I've done, and then this is what you would use for later. And then we have stored this information in the short-term memory, right? Which automatically will propagate to long-term. Now, let's do the same thing, but perhaps with episodic. So I will use the same question with episodes.
My fingers are crossed.
Dev gods. Yeah. Perfect. So one thing, if you notice here, last time when we had no memory, it used 6 tools, right? It extracted run diagnostic twice, it checked recent health deployments multiple times, and so on, right? This time it only used 4 tools. So not only you're making the response better, you're also making it faster, using less tokens, using less number of tools, so that you don't have to repeat the diagnostics again and again, right? Because it has some guidelines from before. So here we have like some learnings from past incidents that we took. So this exact pattern has occurred before. So that's what it took. And then it creates, it looks at the similar episodes, which is there's a relevance score that you can see, which provides how similar was this incident from the current question that is being asked. And remember, we talked about different turn level analysis. So this was the turn level extraction, and then there was a full episode level extraction, right? So this step 1, step 2 is like where it analyzes based on different turns, and then it creates a full reflection on the episode level, understanding what happened on this whole episode, right? And now this is just for certain episodes. Now let's do the same thing with reflections.
Yeah. So basically, there are 2 types of reflections. One is at the episode level, because
Yes.
you have the episode. The other is across episodes, the bigger reflection.
Yes.
Is the one, right? Okay.
Yeah. So within the episode, it's just analyzing itself, how did I perform? How was this episode? So so what I want to highlight here is like the reflections that are being extracted are, there's a topic that is given that, hey, this one talks about database collection pool. It creates some hints which are more generic, right? So here it talks about, I don't know how clearly you can see my screen, but it talks about, let's say, this is a critical indicator. So look at this. So what are the important things to look at? What are the things to do for prevention, for example? So the generalized information, the generalized insights that it has created. And another interesting thing it does is to create it based on the use case level. So it not just gives you certain hints, but tells you when to use these hints, so that dynamically you can insert them in the system prompt when it's relevant. Because, so far we've been creating these huge system prompts with like all of these instructions, the rules, and like what only use this when this happens or something like this. We have been hard coding this into the system prompt, all of this. But we're using agents to solve these complex problems, and not all of this can be hard coded into a system prompt, and it shouldn't be. Why are we giving all of the possible information? We should only provide the relevant information to the agent. So that's where this is super critical.
And also, I want to highlight one thing, is like when we are saying, when Akasha, you were showing those like only 4 tools, and then you said that But then because we have the memory enabled their episodes and learnings, that's why you also touched upon the tokens. And I want to double click on that. Because when you look at these, you say that, oh, these are so many episodes and so many reflections, they are huge. How are you saying that the tokens are less? So that's where I want to highlight that you can customize all of these things. So basically, you can, based on the use case, again, it's
Yeah.
all dependent on the use case. Some use cases you might want to give the entire episodes and reflections. In some use cases, you might just want to filter out and say, you know what, I only want to give episode level reflection and the full reflection, and I might
Yeah.
not want to give all the episodes, right?
Yeah.
You can do that. The idea is that we, with our APIs, we provide you with that, filters and stuff like, and you can process that before giving it to the agent, right? So I want to highlight, like, we want to, and sometimes you can just say, oh, certain episodes will be successful episodes, certain episodes
Mhm.
successful. So you should be able to filter out successful episodes, because that's where will give you the most important information in solving the
Yeah.
problem, right?
Yeah. I would slightly disagree on the part where you say that it uses more tokens, because we were doing the same thing before with the system prompt, right? We were hard coding all of this information in the system prompt, but now it's just able to select dynamically of what's relevant.
Yeah.
So it's only able to, let's say, insert this part into the system prompt instead of writing all of the guidelines and all of the instructions that were basically 10 times the size, because
Yeah. No, I agree. But if you
yeah.
further want to reduce it, that's where I
Yes.
think that there are capabilities depending on
Yes.
the use case.
Yeah.
So I agree with your statement, but I just wanted to make sure how you can further optimize it if need, if there is a need, right? Because we're always looking for cost optimizations.
Yeah. Yeah. Like one thing, like how I kind of think about it is, like when you want to give your agent something like a few short learning, right? You want to give it examples. So that's when you can insert episodes. If you want to just give it generalized information that, hey, this is how you should do it, these are the hints, these are the guidelines, so that's when you can use reflections. In some cases, both of them are relevant. In some cases, only one of them is relevant. So that's really depends on your use case, what you decide, and that's where it would come from. So it depends on the use case.
A
Yes.
quick question, as we were, sort
Yeah.
of discussing about the tokens. A quick question: the amount of tokens to actually create the episodes and reflections that are never used aren't accounted for here, right?
So
um
go ahead, Akasha.
Go for it.
So here's the thing. So you are storing all of these episodes and stuff into your long-term memory, right? And if you look at the pricing for the long-term memory and the extraction, it's very competitive, right? So that's number one. The second is you will not know how your users are interacting with the application. And it's literally when you are saying these episodes and reflections are never used, it's actually, I would disagree. The reason is all these episodes and reflections are created while the user is interacting with your agent. And based on your interactions, we are extracting from the short term memory into this long term memory and generating these episodes and reflections. So, right, for this demo, we were actually, using these reflections which were pre-hydrated. But think of it over a period of time. I'm a user. I have, these incidents that I'm literally talking to the agent. Agent is literally creating the episodes and reflections. And when I ask a similar question, then it uses those episodes and reflections.
Yeah.
So it's based on your interaction with the agent. That's number one. Yeah, actually, number two. One we already talked about. Third part that I want to also highlight is that you should always, look at your memory hygiene for the long-term memory as well, and have some, ways. Let's say if there has been a year or something like that, whatever. Again, based on your use case, think about how you can clear out the older memories, right? Again, it's very use case dependent. When I talk to a lot of customers, they want to retain for like 5 years, 10 years. Some customers are like, after 3 months, everything is stale. We want to keep refreshing it. So it depends on the use case, but maintaining the memory hygiene is absolutely important.
Yeah. I think the question is more focused on the number of tokens that are being used, right? I think, like, I'm not so sure if that's the actual case, but I think it's confusing the agent tokens that this agent is that we are talking to with the tokens that are being used to create the long-term memory. And I just want to kind of reinforce that those tokens to create the long-term memory are already taken care of within the pricing model of AgentCore memory, right? So it's automatically, no matter how long or how big the episodes are being created, it is automatically being taken care of. So it's AgentCore memory is doing that for you. It's not, you don't have to run an agent or an LLM to actually do that job. Yes.
Except if you plan to use
self-manage, yes.
strategy.
Yes,
Other than that, if you're using the fully managed one, it's taken care of. And that's why I started with that. But I also wanted to clarify other things.
Yeah.
Those are commonly asked questions, right? So why not address them while we are here?
Yes. And on top, there's more features that you can use. Like we recently launched a streaming option with which you can, so all the long-term memories that are being created in the vector store, it will give you a notification through a Kinesis stream, and you can use that information to perhaps evaluate how important is this memory for you or not, and based on that, delete it if that's the need that you have, or evaluate the utility score of that. So whatever you need from that, right? So you do have that feature available for your further analysis or for your any need that you have.
I think with that, we only have like 3 minutes left. So
yes.
Okay.
3 minutes.
Let's summarize and
let's do that. Yes.
Okay.
Actually, I do have a question, and maybe the question for audience as well. Like, as we are talking about, applicability of this into like the industry, where do you think it could be, most successful? Like, be it customer support, be it like developer productivity, coding assistant, healthcare, any specific examples you want to, highlight? And maybe this question is for audience as well. Where do you think this is going to be most helpful?
I would say all of these are very high level use cases, and it can be useful on all of these use cases, but it will be dependent on the specific requirement underneath these use cases. So for example, if it's a coding assistant, I want to make sure that when we are coding and doing this stuff, it's learning a user's pattern, it's learning how the user wherever I get stuck. So coding assistants, I do feel that this makes a lot of sense. But for other, when you are saying customer support, like when Akasha was showing the incident response, so the point is that you can do with and without in both cases. So it depends on the specific requirements that you have, what user experience you want to give to your users with your application. And that was literally the first slide that Akasha was talking about, that technical expertise is not equivalent to user experience. So it depends on what user experience you want to give. And just to summarize, we talked about the self-learning component. We talked about how agent handles different tasks. You give it a task, you interact with the agent. Based on those interactions, if you have enabled long-term memory, it will capture those as episodes because we did a deeper dive on the episodic memory. But if you have other strategies, it can extract those as well, and you can have multiple strategies at one time. But this talk was specifically focused on episodes. And then there are reflections within the episodes as well as across multiple episodes where we talked about patterns, and Akasha gave you a beautiful demo on the incident response case, and you were actually able to see that it literally figured out the key learnings from the past in the interaction. And also the less number of tools that it called. That was a really good observation. And then those are the things that we covered. We also talked about evaluation, and evaluation is actually even a deeper topic where we want to say, oh, whatever we are fetching from memory is awesome. but what are the other tools that the agent is calling, the parameters that it is talking about, are we evaluating those as well? So it's literally evaluating the overall performance, evaluating each and
Yes.
everything.
I think even for memory, right? Like sometimes the agent overfits.
Yes.
Like I've been using a couple of other common chatbots out there with which they tend to overfit. And it's not,
Yeah.
so that is something you have to evaluate on the agent level with respect to how it's using that memory. Is it,
For
and
sure.
with that, you can tweak and tune your agent. So for example, we were looking at the reflections and the episodes. We were retrieving 2 episodes and 2 reflections, which are relevant, right? We could also, if let's say we realize that, oh, it's retrieving reflections that are not relevant. So in that case, we could change that threshold of the relevance score that we get from the reflection. So we could tune that saying, okay, only retrieve reflections that have a score of above 0.5, something like this.
For sure.
So that's where you're able to learn and adapt.
I know we are at time, so I would just
Yes.
like to wrap. Thank you so much, Mani and Akasha, and thank you so much to our audience as well. Here are some references, and we did share some references over chat as well. Thank you so much for joining our episode, and see you next time. Thank you.
Thank you.
Thank you. Bye-bye.